All right, guys. Yeah, sorry, I got disconnected just now. So this is a continuation of the previous session that we were just talking about on organic chemistry. So remember, I was just looking at the fractional distillation. So this is called fractional distillation. It's all based on the different boiling point of the substances that we're trying to separate. So paraffin has a different name called kerosene. So I was used to the name kerosene, and kerosene is the one that is used for jet aircraft fuel. So I was right, petrol is used as a fuel for cars, and heavy oils is used as waxes and polishers, where they are, well, they're kind of like semi-solid, obviously, as waxes, like candles and stuff. But obviously they melt when they apply heat to it, yeah? So name the process, I already did, fractional distillation. You should be able to spell these and know this from year 9 separation technique. So one use of kerosene and one use of bitumen. So bitumen is a very common one. So this is for making road surfaces. So those black color, well, kind of like tarred surfaces on the road. So that is made of bitumen. And paraffin, the other name is called kerosene. So that is what they have told you. Paraffin is also known as kerosene. So this is as jet or aeroplane fuel. Well, fuel for jet planes or fuel for aeroplanes. So that's it really on the separation techniques. So moving straight on to alkanes. So general formula of alkane, very straightforward, CnH2n plus 2. Name this, well, they don't tell you, but you know, CnH2n plus 2 is definitely alkanes. And the way we know it as alkane is because of this general formula. And all of them are CnH2n plus 2. You should have a calculator with you that you should be able to check them out. Complete the word equations. So this is a complete combustion. So complete combustion, they could also say in excess oxygen. So in excess oxygen, what you get is you get carbon dioxide, which is CO2, and you also get water, but they want word equation. So that means they want the name and not the formula. Okay, so formula is not accepted, but of course, you know the formula of carbon dioxide is CO2, and the formula of water is H2O. These are part of year 9 dot and cross for covalent compounds that you should be able to draw like this. So dot and cross, carbon has 4 outer shell electrons. Oxygen uses 2 electrons out of the 6 for sharing. You still have 4 more electrons on the oxygen. So those are the common mistakes when students draw dot and cross very, very clearly. So now you have a single bond to the hydrogen there. So there's water, and you still have 4 more electrons left unbonded on the oxygen. On to the next question. So they want the incomplete combustion. Incomplete combustion, they also want the gas, so they don't want any solid. Of course, you could also get solid carbon produced due to incomplete combustion, but they want the gas specifically, so it's not a carbon dioxide, it's carbon monoxide. So this is the gas that is a silent killer. So the formula is just 1 oxygen. Of course, they are not asking for the formula, they're asking for the name itself. This question is basically the same as what I've done for the first bit in part 1. So you should be able to recognize this as the higher boiling point is the one that is 1, 2, 3, 4, and 5. This is a 5 carbon alkane, as they ask you to look for alkane, whereas this is a 3 carbon alkane. So longer chain, larger number of carbons, therefore larger molecular mass, larger MR, therefore larger, well, higher boiling point. This is pretty much the same question as well, so no point repeating a lot of the same thing. So that's CnH2n plus 2. 2 times 8 is 16, plus 2 is going to be 18 there. Moving on to alkenes. So alkenes chemistry is fairly more interesting. You want the color of aqueous bromine. Aqueous bromine means in water, you dissolve Br2. So what you get is Br2 aqueous, which is a mixture because you have Br2 molecule dissolved in water. This is going to be orange. You can also call it orange or yellow, orange, yellow. Okay, so when you add it to ethane, ethane is an alkane. An alkane is what you call a saturated hydrocarbon. Saturated means carbon-carbon single bond, whereas in an alkene, you have carbon-carbon double bond. This is what you call unsaturated. So unsaturated means you have carbon-carbon double bond, and you can do addition reactions. So can do addition reaction. You can add onto carbon-carbon double bond, and therefore this Br2 can add onto this one, but Br2 cannot add onto the carbon-carbon single bond. So no observable change. If you don't see anything that you can observe, that means no observable change. So what color do you see? The color remains yellow or orange. The color remains. Remains means it doesn't change. It's just the original color, orange or yellow. Whereas the other one with alkene, so the bromine water get decolorized, the orange, yellow bromine water get decolorized, or bromine solution in this case gets decolorized. Decolorized means it goes from orange to colorless. So you can also say from orange to colorless. It's the same thing. From yellow, orange to colorless is going to be the same thing. Colorless have no color, just like, well, if we have clean water, then there will be the color that we have for our water. What is meant by unsaturated? So unsaturated is a common question that comes up again and again. Unsaturated means having carbon-carbon multiple bonds. Saturated means carbon-carbon single bond only. State the general formula of the alkenes. So you must be careful with your technical spelling. One wrong letter and you make a mistake. So CnH2n. Next bit is undergoing polymerization. Ethene is a 2-carbon, so it's C2H4. They want the polymer molecule. Before you draw polymer, you should draw the monomer. Monomer is before you get polymer. So the monomer here is something that has carbon-carbon double bond, and it happens to be ethene. So ethene is 2 carbon, C2H4. Carbon from 4 bond, 1, 2, 3, and 4. Carbon from 4 bond, 1, 2, 3, and 4. From this, you should be able to draw dot and cross diagram. So from there, what happened is the carbon-carbon undergo addition reactions. So you have addition. So that means you lost the carbon-carbon double bond, and then you add it onto another of these. So what you have is you have another one of these. So they just keep on adding one onto the other. So this add onto here, and this lost double bond add onto the next one. So they add onto another, and extend that way as well. So this one become and that. So you have n number of monomer, and then this one give you polymer. Polymer is a long chain. So this is a long chain. No carbon-carbon double bond anymore because you have lost the carbon-carbon double bond. Now it's just this structure of the polymer. So actually they don't want the monomer. So drawing the monomer there is just to make you see what is going on. So that is all you want there, which is structure of the polymer. It has to be open chain, meaning to say you cannot have a hydrogen at the end because it's a polymer. Polymer, open chain. Open chain means it continues left and right. So because it's a long chain, so it continues left and right. It just repeat itself left and right, okay? So these are reactions schemes. So this is alkanes. When I look at reaction scheme, if I'm revising, I try to think about what is going on. So this is CnH2n. And then this is hydrogen. So these are reactions of alkenes. Alkene undergoes addition reaction. So this is adding hydrogen across. I could also add steam. Steam is basically H2O, and this is a gas because it's a steam. And then this is polyethylene. Remember, we just talked about polymer just now. So this reaction is called polymerization because I am forming polymer from the alkene that has carbon-carbon double bond to the polymer that has no more carbon-carbon double bond that is now part of a long chain. So there's a polymer, and this is carbon dioxide and a colorless liquid. This is not polymerization. This is not addition. This is what you call combustion. In fact, that is complete combustion because it gives you carbon dioxide rather than carbon monoxide. So the colorless liquid there must be H2O. Of course, they usually want the name for combined science. You should know the name is water. Identify the substances. So B is water. And then process A from alkane to alkene. So you're doing cracking. Am I correct? Cracking? Yeah, cracking. So how in the world do you get short alkenes? You do cracking. Cracking means you break long chain into small chains. So break long chain, so alkane, long chain into smaller molecule, into smaller molecules or shorter chain, something like that. So the process is called cracking. And then process D is what I have labeled as polymerization, because I am forming polymer. So in this context, the ethene is the monomer. So the polyethene, something that has poly, that is what you call the polymer. The polymer basically is many of the monomer, polyethene become the polymer. Substance C is obtained by ethene adding hydrogens. As you can imagine, ethene is the C2H4. Okay, C2H4. Now you're adding hydrogen. You add hydrogen across, and then you have no more carbon-carbon double bond. So what you have is, you have all carbon-hydrogen single bond, and now this becomes C2H6. This is what you call ethane molecule. It's a 2-carbon alkane. Draw a diagram to show the structure of ethene. Well, I've just done that before. I can easily draw that again. Carbon-carbon double bond, unsaturated alkene, carbon-hydrogen single bond, carbon form 4 bond, carbon form 4 bonds, just like that. Last but not least, this is catalytic addition of steam. So we are doing addition of steam. We need around 200, or you can use 300 degrees Celsius, is up to you, which you use H3PO4 catalyst. So H3PO4 is concentrated phosphoric acid. So that's what we do there. Just to complete off, process A is going to be from the crude oil. So this is your fractional distillation. That will give you different product. And then once you have paraffin is still a lot of carbons, but at least it's a pure substance. So you can get 2 carbons, simple alkenes. So how you get this is you break long chain into smaller chain. That is called cracking. Okay, that's it for today. We'll continue the rest next week. I hope it was useful, and I'll upload the same video to the tutorial playlist. And next week we'll add some more with more organic chemistry tutorial. Okay, see you next week. If you got any questions, feel free to text to us. Thank you.